I see. Nice. Okay, so first of all, I will use the fundamental theorem of calculus just to see what to expect. So 6x to the third over 3 plus 7x squared over 2. We don't have any questions on this one, right? Is this clear? Because this is the antiderivative of this function.
Yes, that is very clear.
Okay, perfect. So now I have to plug in 5 and then subtract when I plug in 1. So I'll simplify. So I have 2 times 125 and plus 7/2 times 25, and then minus when I plug in 1. So I have 2 plus 7/2. When I plug in 1, it's just 2 times 1 and 7 over 2 and 1. Okay, so let's see what we have. So this will be 250 plus, I'm just going to leave it for now. Let me see. So what is that? 7. So 400, right? So is it 175, I guess? Correct? Anytime, correct me if I'm wrong, please. Anytime. So this will be 248, and this will be plus 175 minus 7 divided by 2. So that's is it 168? Anytime, correct my numbers, anytime. So 248 plus, I think this is 84, isn't it? And this should be what? 2 and 2 and 3, 3 and 1, 3. I think this should be the answer. We can always check. You have that option. So math and go up. The integration. Okay, so this was from 1 to 5. And that's the x, of course. And the function is 6x squared. And then plus 7x. Okay, so we got the correct answer. Now, let's continue with the limit of the Riemann sum. Okay, so for limit of the Riemann sum, I have 3 preps. First of all is delta x. B minus a over n. B minus a over n. So this is 4 over n. Prep number 2 is xi, which is 1 plus I delta x. Why 1? The lower limit. The lower limit plus I delta x. So this will be 1 plus 4I over n. Prep number 3 is f of xi. So in the function, I plug this in. So it's just 6 times 1 plus 4I over n, everything squared, plus 7, 1 plus 4I over n. Let me stop and ask you if you're with me, or if you have any questions on the way.
No, I'm with you.
Perfect. I got a sip of water. Okay, let me push this. Can I push this further? Yeah. Okay, so now the area equals the limit as n approaches infinity from the summation, let me write it, delta x times f of xi from I equals 1 subinterval till the last subinterval and n goes to infinity. So now delta x is this number. But because it does not depend on I and it's a constant and it's multiplied by the rest, I will put it in front already. So this is limit as n approaches infinity from 4 divided by n. And then I have the sum of this. Oh, no, I'm sorry. I want to simplify this before I continue. I jumped ahead. I don't want to put all this. I want to have it already simplified. So I just want to simplify this a little bit. So I'm going to use a square here. So 6. Remember 3 terms. 1 plus 2 times the first times the second. Plus the second term squared. Plus 7 plus 28. Plus 28I over n. So 6 is outside, the first term squared, plus 2 times the first times the second, plus the second term squared, plus 7 times 1, plus 7 times 4I over n. Now I distribute 6. So 6, 48i over n plus 96 I squared over n squared. 6 times 6, 36, 6 and 3, yes. Plus 7 plus 28i over n. Okay. I'll come back to that page in a second. So now in descending order, this is first 96i squared over n squared. Now here I have to combine like terms, so plus 48 plus 28 I think is 76. Correct my numbers anytime, please. You're saving me from myself. Okay, so 96, this is 60, 76. Okay, this is what I want to plug in. And now I have the summation of this, which is this. Summation of this plus summation of this plus summation of this to cut back on the writing a little bit. So I'm here, bracket. Put this number in front, 96 over n squared times the sum of I squared plus 76 over n times the sum of I plus the sum of 13, which will be plus 13 the sum of 1. Yes, of course they are from 1 to n. It's not correct not to write the limits and the index. At this point, I have to replace this by n plus 1, 2n plus 1 divided by 6. And I have to replace this by n plus 1 over 2. And I have to replace this by n. I'll wait for you to confirm that this is okay. So remember, we had the sum of 3 terms. The sum of this plus the sum of this plus the sum of this. But 96 over n squared is a constant, goes in front of the summation of I squared. 76 over n goes in front of the summation of I, plus 13, the sum of 1. 96 over n squared, the sum of I squared, 76 over n, the sum of I. These are the 3 of the 4 identities that we know. The sum of I cubed, the sum of I, the sum of 1, and the sum of I squared, I, 1, and I cubed. Is this okay so far?
Yes.
Okay, so now it's all algebra, but I have to be careful. So I'm going to do this, a triangle, and continue with the triangle here. So you know where it's continuing. Okay. So I have the limit as n approaches infinity. I have 4 over n. So now I have to rewrite it because I cannot simplify like this. It's too confusing, and I will never do it. And I don't do it for myself, especially when I present. So n plus 1, 2n plus 1 divided by 6 plus 76 over n. And I replace n plus 1 divided by 2, and plus, this is clear, 13n. Now the summation notation is out because it was replaced by these 3 pieces. Okay, and close. Now I'm trying to simplify and see if I can get rid of the denominators. You will never be able to get rid of n. N has to stay, but maybe numbers. So I can get rid of an n from here with an n from here, and the 6, right? And what was it? 13, right? 16. 6 times 6, 36, and 3. Yes, 16. And here I can simplify by 2. And what do I get? I get 38. And that's it. The least common denominator will stay n. There is n here. I will not simplify it. So the least common denominator, this has denominator n. This has denominator n. Good. And this one will take an n because it has 1. So then limit as n approaches infinity, 4 over n. So let's see. The denominator here is n. I have 16, but I have to multiply these two. This is very simple to remember. This is 2n squared plus 3n plus 1. 2n squared plus 2n plus n plus 1. And I will distribute 16. So I have 32n squared plus 48n plus 16. 16 times 2, 32n squared. 16 times 3, I'm checking my numbers. 48, correct. 16 times 1 is 16. Plus, now I'm here. This has to stay. So I will distribute 38n to these two. So 38n squared and plus 38n. Watch me run out of room, but just with one term, and that's not too bad. So plus 13n squared plus 13n squared. So limit n approaches infinity. The denominator now is n squared. 4 can stay outside for a minute, so I can perform these calculations. If I can find my calculator. I think I need a calculator. That's 60, yeah, that's 60, 70, 83. I don't need a calculator. So it's 83 n squared. So this with this, 70, 83, okay. Now 48 with 38, that's 86n. And there is a single 16. So now what I was hoping to see on your homework is using L'Hopital's rule. Some of you got infinity here. That's not possible. This is a definite integral. It has to be a number. It cannot be infinity. So be careful with that. You can put the 4 outside if you want. I still have to multiply by it at some point in time. So this goes to infinity. This goes to infinity. I will use L'Hopital's rule, multiply by 2, 166n plus 86 over 2n. Again is infinity over infinity, and it's 166 over 2 times 4. So 4 times 166 divided by 2. I simplify, and this better be that 130 whatever it was. So 2, so 12, 13, 3, and 1, and 3. So it better be what we got before, because otherwise I have to go back and try to find my mistake. Okay. So remember, this is like from pre-calculus. Same degree over same degree is always the leading coefficient over the leading coefficient. We don't have to use L'Hopital's rule. But let's say we forgot that. So it's infinity over infinity. We love that. Differentiate, you get this. Differentiate, you get this. And then you have infinity over infinity. When you differentiate, you get 166 over 2. And you have the 4 in front. Is this, do we feel better about this now, or?
More or less. I just wanted to make sure that I was doing the problem right.
Okay.
I think I made a mistake in the math somewhere along the way.
It's very easy to make a mistake with this problem. Very easy, right? Very easy.
But I'm definitely doing it right. The math is just jacked up somewhere.
Okay, it's very easy to make a mistake and, forget a term or not multiply or not find the least common denominator. There is a different technique. Isaac used that technique, and I applaud him and I commend him for doing that. If you prefer a different technique, that's fine. I think that this is straightforward, but there is another way of determining this limit piece by piece. I don't recommend it, but I accept it is a good method. If you understand it, if you have a good command of it, it's absolutely acceptable. Good. Anything else you would like to go back to? Other questions from anything? Okay, well, in that case, I would like to continue with That's my page 3. I would like to continue with what is called, this is in section 5.4 still, the Net Change Theorem. It can be used for all sorts of functions. We're going to use it just for one type of function, the velocity. And it's a very, we used this before. So for example, if we want to find the total distance between time t1 and time t2, that will be the integral from t1 to t2 from the absolute value of the velocity function. Do you remember when we used this? But we used it, but we did not use the integration at that time. And that was, if you remember, when we looked at that particle that was going this direction and this direction and then this direction, and we wanted to determine the total distance. So in order to determine the total distance, we went through from this point to this point because it was going in the positive direction, and we used the absolute value of S2 minus S1, and then it reached this point. So this is 1, 2, and 3, the absolute value between S3 and S2, and then it goes the other way, and this S4 minus S3. But now we don't have to do that because the net change theorem, which is this is for distance, there is for concentration, for pressure, for volume, you name it. But we are only going to look at the total distance and see how we determine the total distance covered by a particle using integration this time, not the way we did it before. Okay, so let's take a look. And where is my book? My book is here. Right here. No, right here. Yes. Okay. So that's the last thing that we need from here it is. Okay. So in problems 69 through 70, these two, we're asked to find the displacement and the distance traveled. Okay, so let's look at 70 only because is a quadratic function. 69 will be easier because it's linear. So let's look at 70. So we are given the velocity t squared minus 2t minus 3, and we are given the interval 2, 4, and we are asked to find two things: displacement and total distance. Okay. Good. So here's the idea with the displacement. So let's say at time t equals 2 seconds, the function is here. And in the next 2 seconds between 2 and 4, the function does this. So let's say this is t equals 4. What is the displacement? Is this distance. What is the total distance? The total distance will be this piece plus this piece plus this piece. The displacement is where the function is. It could be on this, where it lands after 4 seconds. It could be here. I don't know. It could be here. So the displacement could be negative. The displacement could be positive. But the total distance, however, adds up this distance plus this distance plus this distance. Okay, so let's see how we determine that. So let's start with the displacement. So displacement is the integral from t1, which is 2, to 4, from v of t dt. No absolute value. So that will be the integral from 2 to 4, from v of t dt, which is t squared minus 2t minus 3 dt. So for now, for us, it's just a piece of cake right now. It's t to the third over 3 minus 2 t squared over 2 minus 3t from 2 to 4. I have to calculate this, so we'll see where it doesn't really matter, but we have to calculate it. We can plug it in and just get the answer. But 64 divided by 3 minus 16 minus 12 minus, when I plug in 2, 8/3 minus 4 and minus 6. Okay, 64 over 3. I get here minus 28 and minus 8/3. And this is negative 10 with minus in front. So 64 minus 8, I think it's 56 over 3. And this is minus 18. So this is 56 minus 18 times 3 divided by 3. Okay, I'm lazy now. Minus 18 times 3, it's 2. 2/3. Measurement unit. I'm sharing my screen. So that is meters. Okay, perfect. Now the total distance. In other words, it started here and it will end in 4 seconds, 2/3 of a meter positive to this side. So this is the displacement from 2 seconds to 4 seconds. Now, part B, the total distance. That is a different story. So from 2 to 4, from the absolute value of t squared minus 2t minus 3 dt, which requires, oops, I passed 22 minutes.